Hi guys, welcome to Edu-Malanga, where we make maths tutorial videos for the South African mathematics syllabus, specifically for Matric at the moment. So glad you joined us. What I'll be doing today is a second example of inverse functions. I covered inverse functions as an explanation. Before that, covered functions in general, which included an explanation of inverse functions. And then I have an example. We have an example video of inverse functions already. So this is the second example. Just house rules before we keep going is that we would love to engage with you guys, hopefully in future and present. But for now, please comment, like, subscribe, and share with your friends. So let's begin. Okay, so the example that I did last week, that we did last time, was pretty much a straight line. This example is a parabola, and an inverse function is pretty much, in summary, the same graph that you would have, but flipped across or mirrored across or drawn again across the line y is equal to x. So if we could draw a mirror along y is equal to x, see my cursor here, along y is equal to x, whatever graph I have on the side or whatever plot I have, I would get the opposite on the opposite side of the line. But not on the y-axis or the x-axis, but necessarily, but on this axis. That makes it an inverse function. Okay, so first I'm going to write out the original function, okay, x squared. X squared, guys, looks like this. It looks literally like that. Okay, alright. So if I was to draw a vertical line here, a vertical line there, a vertical line everywhere, I would only get it crossing the graph once. Therefore, it makes it function. Okay. But if I drew a horizontal line, anyway, it would cross twice, making it a many-to-one function and not a one-to-one function. Okay, so I'm just going to put it here. This is stuff that's been covered before. It's a function, but it is many-to-one. It's been covered before, and I just like to emphasize that you can go check out those videos, or you can use this video and just use how I explained what was previously explained. There are times where you have to say, maybe there's a question that says what kind of a function is, then you would say it's a many-to-one. But often this also helps us realize that when we now do the inverse function, it might not be a function. Okay, so essentially, guys, with a straight line, when I drew the straight line, it was like this. This is for example purposes. I'm not answering the question yet. So when I draw the inverse of whatever straight line, you're probably going to get like, right, okay, but this one is on y is equal to x. So a straight line has one vertical and one horizontal intercept. So it is a function and it is a one-to-one. Therefore, its inverse remains a function. Its inverse only has one point on the vertical side where the vertical line crosses. However, a many-to-one function does not meet that condition, and that's how you know you've done your work correctly. And also, if they ask, is this still a function, then you can say no, it is no longer a function. Why is it no longer a function? Because its graph in itself was not a one-to-one function. So the graph that the question that we get is that this is our function that we're given, and we must now give the inverse function. This is how we denote inverse. So in the question they'll say, please give the inverse of fx, okay? Okay. And we can also plot it, especially if the question asks, please give the inverse function or the inverse of fx. In our scenario, in our case, in our life, the fx is x squared. Okay, so what we did in the first example, what we're going to do again is we first plot the original graph and then we plot the inverse, and then you can already see from that whether it is actually sitting on the mirror y is equal to x. Okay, so in order to draw the graph fx, I'm going to plot 3 points where we can draw the graph at. So at x is equal to -1, at x is equal to 0, and at x is equal to 1. So essentially, I took 3 random points. These are very good points to plot. Okay, this function here is x squared. Okay, so y is equal to x squared. So at f is equal to -1, we get -1 squared. At f is equal to 0, we get 0 squared. At f is equal to 1, we get 1 squared. If you are those kind of people that like making sure of things, use your calculator. If not, we can go. A negative squared is a positive, that is 1. 0 squared, 0 times anything is a 0. 1 squared is 1, because it's essentially 1 times 1. What I get here is that I get a domain and a range. Okay, also, I can actually write this out for you better. Okay, because it's just all the marks are ours. Okay. We're just making sure that no mark is left unturned. I can now write out pretty much the domain and the range of this. A domain is the x values, a range is the y values. If you understand that before I explain this graph, please be patient because I believe in properly explaining. Okay, so the domain is these points, the -1, the 0, and the y. Why? Because the domain is x values. Okay, so -1, 0, 1. The range, therefore, is the corresponding. That word is so powerful. So the value that corresponded to -1 is 1. The value that corresponded to 0 is 0. The value that corresponded to 1 is 1. Okay. That is the graph. Y is equal to x squared. Those are the points. I go here to my graph and I draw a vertical line. The vertical line is the y-axis. I draw a horizontal line. The horizontal line is the x-axis. I'm going to use every single square as 1. On this side, it's a -x. On this side is -y. I can even do that for you. -y. And this side is +x. On this side, we get positive x and then positive y on top here. All this place on top. -1, 1. That is the first point. So I go first with the x, because remember the domain is the x. I go -1, then I go 1. That's the first point. And then I go 0, 0, which is essentially here. And then I go 1, 1. 1, 1. Remember I started with x. We saw with this that already it's going to be a quadratic equation or it's going to be a parabola. It can't be a straight line because it's squared, guys. And then we see with the plot, it goes up and it goes down. So indeed, it meets those conditions. I plot. I don't have to draw it 100%. Done. Okay, now we're going to start plotting the inverse of the function. The inverse, okay, is mirrored across the line y is equal to x. Okay, the inverse f -1. This -1 that we put here, it just denotes, it's like a way of writing. So the inverse f to the -1 x means that the graph, okay, of the inverse of fx. Fx, if you guys remember, fx was x squared. Okay, what we just plotted, it's not a trick question. Which means y is equal to x squared. In order to get the inverse, I simply take where y was and I put an x. And where x was, I put a y. Therefore, for the inverse, it's going to become, here becomes the x. The other side, it becomes the y. Because we interchanged or we exchanged y and x. Y and x. Okay. Therefore, we now know that that's our graph. In the previous video we did it, we're going to do it again. When we now have to explain or denote what the graph is or the function is, we don't start by saying, okay, now we're going to solve it like this. We go to what we're used to seeing. We're used to seeing y is equal to something. So we make it go back there. So if I take this and I square root it, I'm going to get y, right? Okay, so the square root of y squared is equal to y. Okay, but if I square root this side, I'm going to square root the other side. So I square root x. So the new function that we're going to have is y is equal to the square root of x. Okay, so we must remember like certain rules in mathematics because they help us get where we're going, and we're not allowed to break them. Maths has certain fundamental rules that we're just not allowed to break. You can't divide by zero. Also, you cannot square root a negative number. Let's just keep that at the back of our heads. Remember it, because essentially a square root is saying that I squared you. A square root of a negative number is like saying you learn it in university is a square root of I or something like that. But so now we're not doing that. We're not at that level. So we have to then work with what we have. So okay, I'm going to put it down here as a point to say the square root of a negative number is not part of the domain. Okay, so what I'm trying to say to you guys is that the square root of the negative number, we're not going to put it part of our graph. We're going to only look at the positive numbers because that's what we can square root. Okay, I think it would be very beautiful for your examiner if you actually stated for them, because you can already see you're that student. They are like, we're looking for that, and you're like, here is I, here I am in my wholeness, in my. So you're right. You make sure they know you know that you've been watching Edu-Malanga videos. Okay, square root of a negative number, because already you can just see, you would see, I'm gonna get stuck when I have like -2 or -1. So rather just put it down there for them. Is not gonna be part of our domain. Yes, it's not part of the domain. So I say domain because it's x. X is the one that was underneath, and domain corresponds with x. Okay, I'll continue here. So remember what we did in order to understand or to draw the graph is we put certain points. So I'm going to put the inverse function, okay, at point 0. What does that become? It becomes y is equal to the square root of 0. The square root of 0 is 0. You're also allowed to use your calculators, guys. I actually encourage it if you're not confident about certain things you're doing. At 1, we get y is equal to the root of 1, which is 1. Okay. And then we can use another point, another positive point, okay? At 4, we'll get the square root of 4 is equal to 2. So you saw what I did. I just took a couple of positive points, just like the other one. I took 3 points, but instead of taking a negative, I'm not going to take the negative because I've already told my examiner, I've already told my mind, I've already told the graph itself that indeed we're looking at positive numbers because we don't get the square root of a negative number at this point in our. So what this means is that -2 times -2 is equal to 4. Just like 2 times 2 is equal to 4. So I go back here to all my points. So remember, I took only real numbers, only positive numbers, and I put a plus minus. You can't put a plus minus 0 because it's the same thing. But I put a plus minus. Plus minus. Do we see that? Do we get it? I'll just re-explain that. So first what I did is I put just the square roots. Then I was just putting this point again to remind us that every real number has 2 square roots. That is something that you are going to need again for quadratic equations. So note, it's very important to know, and the proof of it is this, that -2 times -2 is 4, because the negative and a negative is a positive. +2 times +2 is still 4. And therefore, if I say square root of 4, I can't just simply say, oh yeah, that's just 2. It's plus and minus 2. Okay, I continue on by plotting the function. Okay, here is my graph and I draw a vertical line for the y-axis and a horizontal line for the x-axis. So we have a positive x and a negative x, and then we also have a negative y and a positive y. Okay, the points that we're first going to draw is at 0. So at 0, we got 0. So I draw here 0, my dot. Then at 1, this 1 here is the x. So I go to x1. But at x1, I get a positive y there. But I also get a negative y there. I think we're starting to see a pattern, guys. Remember I said this is the difference between a many to one versus a 1 to 1. Okay. Yes. You see the vertical line is already going to cross twice. But we're still getting the inverse. Okay, so it might not be a function, but it's still an inverse of a function. At 4, so we go here, 1, 2, 3, 4, we get plus 2 and minus 2. So plus 2, 1, 2, minus 2. And then I plot it for you guys like this, like so. This plot over here becomes the inverse of x, which is the same as y is equal to square root of x. So as we see, if I had to draw the vertical line, I'm not going to get it crossing once, I'm going to get it crossing twice. So this one is no longer a function, but it is the graph of y is equal to square root of x. Okay, and we must remember that the reason it isn't a function is because the original plot that we took it from was a many to one. Okay, because now that many to one became a one to many, and a one to many isn't a function. Okay, so I'm gonna go here with you guys. So I'm gonna first draw the two graphs now on the same plot so we can see it mirrored, and then I'll continue explaining about the domain and what that would do, and perhaps if we were to play around with the domain, can we get another function, or is it going to remain that the inverse is just not a function? So I'm going to first draw in, first draw in black because it's the, first I want to draw the graph itself, the axis, sorry. Okay, so this is the x-axis, the y-axis. Okay, I'm going to put here negative y and positive y because that's like reminds us what we're drawing. And then I also need to plot here the x-axis. This is the x-axis, horizontal. So alongside the horizon, if we were to look at the road, this goes with the road, goes with the ocean, goes with whatever is horizontal. Positive x is on that side. The original graph that we had, if you remember carefully, was y is equal to x squared, and then it gave us a couple of points, and the plot of it became something like this. It's not the most accurate, but that's what the graph was. It was y is equal to x squared. Then we plotted its inverse. The point that we had was 0, 0, and then we had a point here, and then we had a point here at 4, 2. Okay, so I'm going to draw it like that. And then we set it on the side. And then this was the graph of y is equal to square root of x. If I were to draw a mirror line here, for you guys, called y is equal to x, it shows that I've mirrored the graph. Okay, so I'm not mirroring it across the x-axis. I'm not mirroring it across the y. I'm mirroring it across this. The best that we would produce is that. And that's how you prove to yourself and you check yourself to say, indeed, you drew the inverse. Okay, so if we restrict the domain if we restrict the domain to positive values of x, okay, how we write this is if x is only it's either 0 or higher or bigger than 0, then f itself, right? So essentially I'm saying I'm not looking at these values. I'm just looking at fx from this side, okay? Then what I get is if I cross it here, I get at 1 point. And if I cross it this way, I get 1 point because this ceases to exist. This no longer exists. So we get now a one-to-one function. Okay. So if x is a 1-to-1 function, this means that I can now plot the graph and its inverse like this. So I'm going to plot the same graph we just plotted, but now I'm only going to plot the positive points of it. So if we go back to the previous slide, I'm plotting only this positive part and only that positive part. So for x squared, I'm going to plot only this. For this only corresponds to those values. Okay, if I mirrored it like that, both its inverse and its function itself are functions. Okay. Again, if I again restrict the domain, if we again restrict the domain, if the domain is restricted to negative numbers. In the previous one, we restricted it to positive numbers. In this case, I am restricting it to negative values of x. Okay, so x again, now I'm looking at from 0, negative. So x becomes a number that is smaller than 0. That's how you write that. If the open side means the bigger, so 0 become bigger. Okay. Then f is still going to be a one-to-one function, and so will the inverse. Okay, let me draw it for us. Look at the negative values of fx and f minus 1x or f inverse, right? So if I look at that, I'm just looking at this part of it and this part of the graph. Okay, so the first parabola, I'm looking at only these points, and the other graph, I'm only looking at those points. If I were to draw the line, y is equal to x, again, I get the mirror on each side. And in this case, because we restricted the domain, we get a function and a function. Okay.